Hey there, beautiful people. So in this section of acids and bases, we're going to talk about pH, and this is where our calculations come into play. So we're going to spend a majority of our time in pH as opposed to pOH, which I'll show you on the next slide. Now, one thing I want you to know is whenever you see pH, this little p is what stands for negative log of. And then whatever comes after the P is what you're taking a log of. So we can see it here. pH is used to determine the H plus in a concentration. In a solution. So we're looking at this formula. So in the terms of pH, pH equals the negative log of the concentration of H plus. Anytime you see these brackets, know that that means molarity. And from here on out, anytime I talk about concentration, I'm always talking about molarity. So we're talking about, again, that is big M. Now, H plus will be small numbers, meaning they will be something times 10 to the negative exponent, whatever it happens to be. So something like 1 times 10 to the negative 7 molarity is what we're talking about. They can get much smaller than that as well. They run the range of anywhere from 1, typically around 1, to 14. Now, your range is what's important. If your substance is less than 7 on the pH scale, you're going to be acidic. If your substance is exactly 7, that means it's neutral, meaning it's neither acid nor base. And if your pH is greater than 7, then your substance is going to have basic properties. So here we're talking about, remember that we're talking about H plus or loses an H plus. And here we're talking about OH minus or gains an H plus. Depending on which definition you're doing. You're talking about Arrhenius, you're talking about H plus and OH minus. If you're talking about Bronsted-Lowry, we're talking about H pluses loss or H plus gains. Well, proton, but for our purposes, we're always going to talk about H pluses. Okay, so let's look at the pH scale. So here's a great little comic scale of the pH. So on the left, this would obviously be all acidics down here on the left-hand side. And obviously everything on the right will be basic. Everything over here will be basic. So anything from 0 to just around 7 will be acidic, and just 7 and above to 14 will be base. Now, you look on the left-hand side, we have things like HCl, which is an acid. Anything this extreme can cause damage and death to your body. Now, you'll notice that stomach acid, which is also HCl, is also way down there. This is why when you throw up or you regurgitate in your mouth, your throat burns. That's because the inner lining of your stomach has a coating to prevent the acid from burning through your stomach. But when you throw up, all of that acid goes up your throat and there's no lining there and it burns. You're literally eating away at the acid, the skin and the flesh of your throat. People who are bulimic, who throw up in order to make themselves thin, typically have bad teeth. Why? Because your teeth are made of calcium. Calcium is a metal, and it's in a form of metal. It's a metal on the periodic table, and when it reacts with the acid, it starts to get eaten away. A good way to remember that, talk about anything that is sour and burns will be an acid. So lemon, vinegar, burns in a cut especially. Lemon juice, orange juice, any citric acid, vinegar is in here. As you get towards the middle, you get into wine and coffee. Right around the center, milk is slightly acidic. That's the lactic acid that's sometimes in there. And then as you move up, blood is slightly basic. It's usually around a 7.4. And we get more and more. Baking soda, which is sodium bicarbonate, when it mixes with water, forms a base. Milk of magnesia you take when you have an upset stomach. It counteracts the acid that's in your stomach because it's a base. Ammonia, very toxic to the nose. Base. Soaps, anything slippery, bitter, are going to be bases. And of course, you have drain cleaner like Drano all the way up here. Super basic. That stuff takes care of things in your pipes. Okay, so now let's talk about the opposite. Let's talk about OH. So you can calculate pOH the same way you calculate OH. we're going to use this formula. Now, here's the weird thing. Even when you have a strong acid, there's always a little bit of base left behind. There's always a little bit of OH minus. And in every strong base, you have a little bit of acid. So what we know is pH and POH are opposites. This formula is going to be super important to you. So don't forget it. pH plus POH equals 14. We can go back and forth between pH and POH, H plus and OH minus. I'm going to show you how to do this on the next slide. Now, what you need to remember are these two facts. Anytime we talk about strong acid, we're talking about H plus, and anytime we talk about strong bases, we're talking about OH minus. So strong acids are things like HCl, HNO3, H2SO4, etc. Those that were on the previous video. And sodium strong bases, we're talking about things like sodium hydroxide, like that. Okay, so you're going to see the OH here and the H there. Now, pull out your calculator. Let's do some calculations. I want you to take a space in the middle of your notebook, and I want you to draw in this little chart. In the left, I want you to put H plus. On the upper right, I want you to put OH minus. On the bottom left, I want you to put pH. And on the bottom right, I want you to put POH. Okay. Now what we're going to do is we're going to draw lines connecting them. Like this. Not lines, arrows. Okay. Now, technically, there's a line that connects H plus and OH minus, but for the purposes of this class, we're just going to ignore that calculation. So what the arrows tell us is what to do when you're going from one spot to the other. So, for example, if I have H plus and I am going to pH, I'm going to do the negative log of the H plus concentration. Okay? And just the same thing on the opposite side. If I'm going from OH minus to POH, I'm going to go negative log of the OH minus concentration. If I want to go in the opposite direction, and I want to go from pH to H plus, then I'm going to use the inverse log. Now, on the calculator, and I'm going to show you this in a second, it's going to look like 10 raised to the negative pH. And the same thing for the POH. It's going to look like 10 raised to the negative POH. Now, going between pH and POH is simple. If you want to go from pH to POH, we're going to use that pH plus POH equals 14. So we're going to have 14 minus the pH will give you the POH. And if we're going in the opposite direction, it's going to be 14 minus the POH equals the pH. Now, to do any calculation, we're just going to use this format the whole time. Okay, so here's what I'm going to do. I'm going to take this off the screen. I'm going to put up the chart again. You're going to pause. You're going to write down this chart, and then we're going to fill it in together. Okay, so here we go. I'm going to use that chart. I'm going to keep referencing it. I'm going to bounce between all of these different things. Now, the easiest thing to do is to go from H plus, I'm given this number. So I'm going to go to pH. And in order to do that, I'm going to go negative log of 6.4 times 10 to the negative 6. Now, you don't have to write this into the square if you don't want to. I'm just doing it so that you know where my calculation is coming from. So negative log 6.4 times 10 to the negative 6. Now, let me show you how that looks in the calculator. So here we have our handy dandy calculator. Your calculator might look a little bit different, but I'm going to type in negative. I'm going to turn my calculator on. We're going to type in negative, and now you'll see the log button is here on the left-hand side. You should find a log button on your calculator as well. And you're going to type in this number and hit enter. And so I get an answer of 5.19, blah, blah, blah. I'm going to round it to 2 places past the decimal. So 5.19. Now, if you are doing this on your phone, especially iPhone specifically, and you're using the scientific calculator on your iPhone, everything has to be entered in backwards. So you're going to type in 6.4 times 10 to the negative 6. Then you're going to hit the log button. then you'll hit the negative button. And if you do it that way, you'll be fine. You'll get the right answer. Okay, now to go from pH to POH, I'm going to go 14 minus the pH is going to be my POH. So I go back to my calculator and I go 14 minus second answer, enter, and that's 8.81. Now I'm going to come back and do the OH minus. I go back to my little chart. I'm in the POH corner, so I'm going to go up to the OH minus, and in order to do so, I'm going to go 10 raised to the negative POH. Oh, in this case, it's 8.81, so it's going to be negative 8.81. And on the calculator, it's going to look like that. It's going to be second log. Now do you see this 10 raised to? Now, if you can't find the second log button or your calculator doesn't have a second button, you should see this 10 to the X button. 10 to the caret button. If nothing else, you can always just type it in as 10 caret like that if it gives you the exact same answer. And I'm going to type in negative 0.8.81 and I get 1.55. Again, I'm going to round it 2 places past the decimal. 1.55 times 10 negative 9. Now I have to determine if this is acidic or basic. So I think about my chart of pHs, and I know that anything less than 7 for pH is acidic. Anything greater than 7 for pH is basic. This is less than 7, so this is acidic. Let's do the third row, because the second row is very similar. Let's start with the third row, and it doesn't matter which order we go in. We can answer any of them. First of all, I'm going to answer the easy question. This number, this pH, is less than 7, so I know that it is acidic. Now I'm going to go into POH. From pH to POH is following along the bottom. So I'm going to go 14. That was a terrible 4. Let's try that again. 14 minus the pH will give me my POH. So that's going to be minus 3.2. So I go to my calculator. 14 minus 3.2, 10.8. Now, I can go to either H plus or OH minus next. It does not matter. Since I was given my 3.2 as my pH, I'm going to go to H plus first. I know by my chart that 10 raised to the negative 3.2 will give me my H plus. While I'm here, I might as well go 10 raised to the negative 10.8 for my POH. I'm sorry, for my OH minus from my POH. Now I plug those into the calculator. Second log, or 10 raised to the negative 3.2, is 6.31 times 10 to the negative 4. Do the same thing for my OH minus. Second log, negative 10.8, 1.58 times 10 to the negative 11. Okay, so now at this point, you're going to pause the video. You're going to do the other 2 lines by yourself. I'm going to go work off to the side, and I'm going to do everything else. I'm going to fast forward through all of this, and I'm going to show you the final answers when we're done. So ready for like quadruple speed? Here we go. Okay, that's it. That's how did you do? Pretty good? Did you get everything right? Fantastic. Now, I want to show you one last little trick. I want you to compare this column and this column. Look at your exponents in each of these. Every single time, no matter what, they always add up to negative 15. Okay? Negative 6 plus negative 9, negative 15. Negative 10 plus negative 5, negative 15. Negative 4 plus negative 11, negative 15. Negative 13 plus, technically, this is negative 2. This is 7.9 times 10 negative 2. Negative 2 plus negative 13, negative 15. So when you're doing a chart like this, it's a really easy way to double check your H plus and OH minus amounts, because they always add up to negative 15. So just a little side thing to make sure you're on the right track. That's all. If you have any questions, obviously ask.